Welcome to Stormwater Drainage Solutions. In this video, we're going to be installing some ADS dual wall drainage pipe. I'm going to be walking you guys through this job install, as well as talking about the pipe and how we are doing the job here. So as you can see, we already pretty much have our trenches dug, and we're going to be discharging this system out the back through the seawall. Now, we did decide to go through the landscaping here because this was the easiest path to take with the drainage pipe. Because as you can see right here, we have a lot of concrete that we would have to cut through otherwise, and this would just increase the price of the job. So to help save on the client's budget, we decided to just go through the back of the landscaping. Now, dual wall drainage pipe has a smooth interior and it has a corrugated exterior, and it comes in 20-foot sections. Now, we decided to go with a smooth interior pipe on this particular install because we want that increased gallons per minute, that increased flow rate, because we are going to be taking on a lot of water that we need to manage here. We're going to be going underneath this sidewalk here, and then ultimately, this pipe is going to be responsible for discharging a new channel drain that's going to go across the driveway here. The issue that we're having is this micro channel drain that the builders installed. It doesn't go anywhere, and water floods into the garage because the driveway is pitched towards the garage. So we're going to install our drainage pipe to connect to the channel drain to fix this issue. Now, as you can see here, we're tile taping up a couple of joints that are being created by this 45-degree elbow. Now, dual wall drainage pipe, it has bend to it. You can actually flex this pipe and you can bend it. But I would say that you can bend it probably no more than about 22 degrees or so. You don't want to bend it and flex it too much, because if you do, it will start to ruin the inside of the dual wall, that smooth interior. So anytime you have a 45 degree or more, you need to use joints on this pipe. Now, the reason we are also tile taping it is because that's going to be an extra layer of defense. Now, dual wall drainage pipe, it comes with rubber gaskets, and we use the rubber gaskets on all of our joints, but we also like to tile tape it because this just adds an extra layer of defense against tree roots and against possible pipe separation in the future underground. You can see right there how that dual wall kind of flexes around where that footer to the wall is. That's another reason we like to use this pipe, because it does have some flex and some bendability to it. So you can see the men here are working in the landscaping to get that pipe in. This is also going to make for a cleaner install though, because once we are done installing this pipe, it's going to be a lot easier to clean this job site up and make it look like we were almost never there. Now you can see I was hooking up and testing a piece of the pipe right there because I'm actually putting a clean out on this corner of the pipe. We're going to have two clean outs on this system. We're going to have one on the end corner here and then one on the beginning corner where those 45s are. Now, obviously, the channel drain will act as a clean out too, and then the discharge point will also act as a clean out. So essentially, you will have 4 points of access on this drainage system. Now, it is important whenever you're installing drainage pipe that you do want to have access to the system for future maintenance, and if for any reason it ever just needs to be cleaned out or inspected. So make sure when you're installing your drainage pipe, you do have more than 1 point of access. Obviously, the discharge end is going to be a point of access, but you want to also probably have a point of access in the middle of the line somewhere, as well as where the system is collecting water. Now, as you can see here, I'm having to widen up the hole that was already in this seawall. There was an existing 2-inch PVC line that went through here. We're not really sure why there was an existing 2-inch PVC line in here. The only thing that we could speculate was the PVC line was put in here from the seawall installer, for future drainage if it ever needed to be hooked up. But obviously, we don't want to go down in size. We only want to go up in size with drainage. So we're just simply going to use a hammer chisel and open up that hole a little bit wider. This is not going to mess up the concrete. This is not going to weaken the concrete at all. There's rebar in this seawall. As long as you make that hole wide enough for your pipe to fit through and you're not having to crush your pipe down, the seawall, the concrete is going to be fine. Now, once we have this hole wide enough for our pipe to fit through, We're going to go ahead and test it with a piece of our dual wall drainage pipe and make sure that it fits right through and that there's no issues. And as you can see here, we push that pipe right on through and it fits like a charm. That's going to fill up the majority of the void. The next step is going to be using hydraulic cement on both sides of the seawall to close in the remaining void around the pipe. So you can see I'm down in the water right now, mixing the hydraulic cement up, and I'm going to be putting it around the pipe here on the outside, and then one of the men is going to then mix up some more and put it on the inside of the seawall. So we didn't get a lot of that on film because with hydraulic cement, you need to work quickly, you need to move fast, because hydraulic cement has additives in it that make it harden up very quickly. I would say working time with hydraulic cement, you have roughly 5 to 8 minutes to get it set in place, smoothed out, and how you want it before it hardens up. Now, for this system, we are going to put a catch basin here in the beginning, and the reason we're going to put this catch basin here is because any debris, sediment, sand, things like that that get into the channel drain, that get flushed into the system, we want to have a way to catch it before it goes into the pipe, because this is a pretty long run on gravity, and it's all gravity fed. So we want to try to keep dirt and sediment out of there the best we can. Now, that catch basin is going to catch a lot of that dirt and sediment before it gets into the actual drain line that runs and leads all the way out here to the back. So that is the purpose for that catch basin, is to catch any debris before it gets into the system, to try to keep the system a little bit more clean. Now you can see here Miguel is kind of running through the system right now. He has the garden hose running in the pipe just to make sure that that water is going to be flowing all the way to the back like it's intended and draining out. And as you can see, we have a nice flow coming out the back here. Now on this particular project, we had a decent amount of fall to work with, obviously because of this massive drop where the seawall is. So gaining our fall on this project was not that complicated. But to keep in mind, whenever you're working on a seawall or somewhere where the tide can rise, so the tides will rise and fall. So just because you have a lot of fall to work with doesn't always mean you want to take advantage of all that fall, because ultimately you want to keep in mind that those tides will rise. So we want to keep our drainage pipe up high on that seawall. That way when the tide rises, it doesn't put that pipe underwater all the way. Now, if it does go underwater a little bit, that's not a big deal, because obviously the point of collection is up a lot higher than the point of discharge. So the water is not going to backfill that far through that pipe, and that pipe will still be able to push water out from the point of collection, because it is going to be working off of head pressure and the gravity moving that water through. But just to be on the safe side, you always want to try to keep the pipe elevated whenever you can. So you can see here, we're getting everything prepped to start cutting concrete. We put plastic and tape up to cover the garage door. That way we don't get the concrete slurry all over the garage door and on the walls, because when you are cutting concrete with any type of wet saw and you hook up water to it to keep that blade from getting too hot and to cut the concrete a lot easier, you are going to make what is a slurry of a mixture of concrete, dust, and water. So this will kind of splatter and it will get on things. So if you prep the area with plastic, it will make it a lot easier when it comes time to clean up. So you can see here Miguel is running that walk behind concrete saw. We like to use walk behinds a lot now. You know, we are getting older in age. Having to be bent over with an actual hand saw and be on the ground cutting is just a lot more difficult. So to save our backs and our knees, we have been utilizing a walk behind concrete saw for a while now. It makes the job a lot easier, a lot quicker, and you can get a straighter cut with this. But obviously you can go slower. You're not having to hold a concrete saw and be bent over, struggling with it. So the walk behind makes things a lot easier. So whenever you are cutting concrete, I will say you want to make sure that there is a water source around, because it is going to create a ton of dust if there isn't water being constantly put on the blade and on the concrete as you're cutting. So once we have our line cut, we're going to go ahead and use the pry bar here, as you can see, and we're going to break those sections of concrete out. So a lot of times the concrete will come out pretty easily if there was minimal to no rebar used. But if there was a lot of rebar used or mesh used in the concrete, then it does not come out quite this easily, and you have to chisel it and jackhammer it out. So once the concrete's out, we remove the micro channel drain and we get our larger channel drain in place. Now on driveways, we like to use a metal grate because there's going to be vehicle traffic going over this channel drain. So on driveways, we like to use a metal grate, but then on pool decks, we like to use the plastic grates. And the reason for this is because a pool obviously has chemicals in it. It has chlorine, has other chemicals for the pH balance. Or if you have a saltwater pool, it has salt in it. That water potentially can splash and it's going to go into the channel drain. It's going to wash across the grate. A plastic grate is going to hold up a lot better over time in that situation where it's being exposed to chemicals or salt, whereas a metal grate is going to rust a lot quicker when it's exposed to chemicals and salt. So we save the metal grates for where there's going to be vehicle traffic, and we save the plastic grates for the pool decks and where there's going to be chemicals. If you enjoyed this video, give us a thumbs up. It really supports us. It supports the channel. It helps out what we do. We're going to keep coming at you with videos. And if you're in the Tampa Bay area and you need drainage, whether it's downspout drains, channel drains, French drains, give Stormwater Drainage Solutions a call at 813-614-3456. We install dual wall systems, PVC systems, corrugated systems, triple wall. If it's drainage pipe, we got you covered. Give us a call.